So this objective is also part of the Natural Hazards Weather lecture series. And in this one, we're going to be focusing on severe weather and how we can predict and prepare for it and how they actually happen. So lightning is something that happens a lot with storms. And it tends to happen because clouds brush against each other and by doing so, rub literally electric particles off each other. And that causes regions of the cloud to be polarized or have more charge of one kind compared to another. And so a lot of lightning actually happens between clouds due to this, as the charge tries to stabilize. But if this is happening in the clouds and not happening on the floor, there's also going to be a difference in charge between the floor and the clouds, and that can lead to a lightning strike that goes towards the floor. Now, actually, the charge of the floor tends to be neutral compared to negative charges that build up in the clouds. And so the charge would actually jump in that direction because the current flows up from positive to negative. So that means lightning strikes are actually from down up. But before the striking actually goes down, typically you have these little feeder lines that all spread, trying to find the easiest path down. And as soon as it connects to the ground, a sudden discharge of energy will actually happen down up towards the cloud, neutralizing the charges, and that's lightning. Now, of course, if there is lightning happening, there's weather devices to detect that, and usually, especially where there's sparks and stuff like that, there's always an early advanced system, especially if you live in a civilized first world country. Now, you are supposed to seek shelter immediately if you see that happening, or if you see a storm in the horizon with lightning happening. And that means inside of a building, protecting with a lightning rod, or a car or vehicle that is covered, because it acts like a Faraday box and protects you. I've actually been hit by lightning in a car before, and nothing happened to me because I was inside of the car. Crazy story. But anyways, they're essentially electrical discharges between the clouds or the clouds and the floor. Now, there is thunder, and thunder is basically the sound that you make when lightning cooks the air and causes a sudden shock wave of energy as that electricity is hot enough to literally cook the air and cause chemical reactions to happen between the particles in the air. And it makes ozone, it makes nitrates and nitrites. You have all of this natural production of chemicals due to the sudden release of energy. And that's actually important for the atmosphere. And there's lightning happening all over the world. Every single second there's lightning strikes happening. So the atmosphere is constantly being changed by lightning. But that sudden shock wave also causes a sound wave, which is the thunder. But sound travels slower than light. And so it takes a while for you to notice that the lightning struck. Unless it just struck on top of you, which in case you will hear the thunder at the same time. And that's usually bad news. All right, people do survive lightning strikes if it doesn't go to their heart and if it doesn't burn their bodies enough. But people are struck by lightning every day. So it's not, and by the way, it can't strike the same place twice. Absolutely, especially if there's a reason why that place keeps getting charged. So yeah. Anyways, because of the speed of sound, every second that passes is about a fifth of a mile or 343 meters. All right, so that means that in 3 seconds it travels a kilometer, and in 5 seconds it travels a mile. So if you call 1 second, 2 1,000, 2 1,000, 3 1,000, 4 1,000, 5 1,000, and then you hear the thunder, it's only a mile away. So even 5 seconds is really close. Get to shelter. That's what that's about. Now, lightning, of course, will happen in all kinds of severe weather systems, including tornadoes. Now, tornadoes will happen when in places where hot and cold airs collide, especially when you have really hot air and cold fronts coming in. So in the Midwest of the United States, especially during the summer months, it gets really hot. But then you have cold fronts coming from Canada and the polar regions, and that brings collisions of air masses, which causes tornadoes. Now, you really need to know how tornadoes form, but they're essentially extremely violent storm with rapidly rotating winds that happen because of updrafts of warm, humid air rising really, really fast on those hot versus cold air collisions. Now, if the upper level winds are also moving laterally to each other, that creates rotation in the cloud, which ends up getting worse and worse and causing a tornado to take place. They are features of thunderstorms, that's for sure, though. Now, if there is a tornado and you are indoors, get to a safe room that's very stable, away from windows, usually a basement or a storm cellar. If there is no basement, you can go to a small interior room on the lowest level of your house and use your arms to protect your head and neck and stay away from doors and windows. Some people have survived by going inside of bathrooms without windows, inside a bathtub, covering himself with a mattress, which is can happen, can help with earthquakes too. But anyways, outdoors. If you are outdoors, get safely in a building that is built to survive tornadoes as soon as possible. But if there's no nearby, a vehicle can help, even though vehicles can be picked up, and so you better buckle up. And a best place would be underneath an overpass or a bridge or a location that allows you to have overhead protection. And make sure whatever you do that to watch out for flying debris and keep your head low, because that is also kills a lot of people. Just the stuff that's flying around, picked up by the storm. Now, imagine a tornado which can get to hundreds of miles an hour winds, but in massive scales. And that's what you get with a hurricane, a storm the size of an entire state or more. Now, the way it works is that warm, low pressure systems coming from the Sahara Desert, really hot air, get pushed by winds over the Atlantic, and then that causes a massive amount of evaporation and moisture to be picked up by already hot water. So remember, the key for these storms is hot, moist air and heat. That's what causes and feeds them. So in the case of the hurricane, that's exactly what will happen. It's fed by the hot tropical water and the low pressure system coming from the African deserts. Now, the storm itself is huge also itself. All of those are factors of intensity. All right. The lower the pressure in the middle, the bigger the storm is, and the more hot water it's pulling, the stronger the storm is going to be. And you actually can use that to predict the intensity of these storms. Right now, a Category 5 hurricane will have winds over 150 miles an hour. It will cause tornadoes within the storm, and it will cause a storm surge so bad. That's actually what a lot of people don't realize. That's what kills. The wind will push the ocean forward, and as it hits the land, it will cause massive waves that will do a tidal-like overtake of the land, which will cause floods. It kills a lot of people that stay behind, protected in their house, which are hurricane safe. They flood. So if you live in an area, knowing where you live is the key part. If you live in an area that's likely to get flooded, you cannot stay there. And if it's a really strong hurricane, even if your building is coded for it and designed to support it, it's just one of the things we do, by the way. We design better buildings, aerodynamic buildings, roof structures which are sustaining those winds. And we also can shutter down the windows, right? Now, in the case of a tornado, there's no time to do that. But if you also live in an area that has tornadoes, you can build smart and definitely have places with underground shelters, right? But anyways, knowing where you are is crucial. And knowing if you have to evacuate is crucial as well. The best thing you can do is probably evacuate after boarding up or shuttering your windows. Because if the window breaks and then air was going to push inside, it can actually rip your roof apart from all the pressure of the air going inside of your house. So it's very important to protect your windows. And of course, debris flying around can hurt too. So that's another reason to board up your windows or actually use shutters. And the most important thing to prepare in the case of a hurricane is to have an emergency kit, and that can be helpful for a tornado as well, that has things like food that does not require cooking, water, first aid, and communication devices that allow you to actually find out what's going on. Now, in the case of a hurricane, once that spiral starts to rotate, right, because of all the evaporation, clouds form all and out around it. And then the Earth's rotation also helps spin the storm. And when the storm passes over land, the supply of moisture stops, but it does carry that wave and that rain over it, and it causes a lot of destruction. So at around 74 miles per hour, you get what's called a tropical Category 1 hurricane. Below that, you have a tropical storm, and below that even, you have a tropical depression. And then they go up in categories by strength of winds and pressure, all the way up to Category 5, which has very, very low pressure in the middle, extremely hot, moist water feeding it, and very large storms with very large sustained winds over 150 miles an hour. That's one of the most destructive things. It actually causes one of the disasters that causes the most death in the continental United States, because we have good, safe buildings for earthquakes. We can tell if our volcanic eruptions are coming, but tornadoes and hurricanes are very dangerous. In Colorado, wildfires probably a more serious concern, but these are important to know about as well. Now, there's a lot of weather instruments that help us predict and detect the weather. There's Doppler radar, which is basically they launch light waves, radar waves, which is radio waves really, into the storm, or infrared. Depends on if you want to go to the clouds or not, or how deeply you want to go into the cloud. And then the way that light reflects back and gets detected by the radar can tell you about the density of the clouds and therefore how much precipitation is likely to come along with it. But satellite images are even better because it actually shows the cloud cover over long regions, and you can actually see the entire weather system coming. Doppler radar is for like an immediate 5 minutes from now, you're going to get a big thunderstorm and a lot of lightning, which is actually how a lot of lightning and warning systems actually happen. There are also some lightning systems that detect changes in the electrostatics of the atmosphere. And there's a different device that I actually didn't even mention here. But these are the two main ones to actually help you to detect incoming weather systems and cloud coverage. Now, you also have wind vanes and anemometers. Wind vanes will tell the wind direction, and anemometers will tell you the wind speed. And they look like that. And then the barometers are going to be the things that measure air pressure. And remember, those are very important for weather patterns because the way that air pressure changes can tell you something about the storms that are coming. And we'll talk about that again on predicting the weather on the next video objective of this series. Then you have thermometers, which also measure air pressure, which aside from the obvious how hot it is today, can help you determine the dew point, which is the likelihood of things to condense, and also the amount of possible cloud formation because of all the evaporation that comes when there's a lot of hot air, right? There's a pyranometer, and that's just a device that detects the amount of intensity of the solar radiation, including ultraviolet radiation, which is an important component. There's also devices that measure the ozone level, which can lead to a higher pollution and smog formation in the atmosphere. Ozone is usually higher in the actual atmosphere, but it can form at ground level due to a lot of processes, including lightning. And so I didn't put that here, but ozone measuring devices are also included in weather stations. And you have hygrometers or psychrometers, which are two different types of devices which help measure air humidity. And of course, that's very important because humidity comes along with cloud formation and possible precipitation. So very important to measure that. The rain gauge is a device to measure the amount of precipitation after the fact. And then you also have weather balloons, which measure the weather higher up in the atmosphere into the stratosphere. Will measure the jet streams, the wind speed, wind temperature, and those high atmospheric pressure systems can also move entire cloud systems over in their jet streams. So they are important. The jet streams will cause weather systems to move in specific patterns. So that's actually very, very important. And there's some other weather devices that I included here just for kicks. And I even have some pictures of some weather stations for you to see how they look like. And finally, about barometers, there's a couple questions in the test that talk about how they work. Now, the first barometers basically worked by having a tower of mercury, which is a liquid metal. And as the pressure increases, it actually pushes down on the liquid, causing it more to go inside of the barometer and then the level to rise. Nowadays, there's a similar principle, but they're mostly digital or analog, and they're not relying on the liquid inside anymore, but more on the deformation or the squeezing of a chamber that has vacuum inside. And as the pressure outside changes, it will squeeze the device. And as the device deforms, it will detect changes in pressure that way. And even inside of cell phones and digital devices nowadays, you can have tiny leaves that do this job, metal leaves, and that basically is how most barometers nowadays actually work. All right, on the next video, we'll pick it up talking about another objective that actually going to talk about how you can predict weather by looking at these measurements that we take.